Hey guys, it is Rick Slade, Compuware's Executive Solution Architect for DevOps. And again, I'm glad you joined us for our office hour, Rick Slade. We do on Fridays, 11 o'clock Eastern Time every Friday. Again, we're glad you're joining us and hope you've got questions that we'll be able to answer. I look forward to this every week. This week's kind of special though. I'm going to hold up the camera and see if you guys can see the background. So we are on vacation this week. I wanted to take a few minutes just to respond to questions that we've got. We've had, man, it's been a wonderful week. I've got my entire family down here this week, and we just have a great time. We've been doing this is my 45th year. So it's been great. Had a good time. Family enjoys one another. So this is one Friday. Kind of sad to see it Friday because it means the end of our vacation. We'll head back home tomorrow, and then we'll back to work on Monday. So, but it's been a good week, and we've appreciated it. So let's see. Let me get to some questions. Let's see. And we'll get started quickly today. We spent some time in the podcast Monday talking about program analysis and application understanding technologies. You know, I always group those technologies and those tools into the DevOps toolchain. I think they are critical. Some people don't. I think most people are starting to see now that DevOps encompasses that entire software delivery lifecycle, and they are critical. Anything that we can do with regard to minimizing or reducing time in that development effort is very, very important. So I think that I was telling a story to some folks the other day. Maybe I mentioned this in the podcast. A few years back, I headed up HP's application modernization practice, where we were modernizing the stack, and we used to keep intricate metrics, details on the work, as you would expect. And there were two things that had or consumed the most time in any significant project of application reengineering or modernization. Number one was always testing, and that included all testing as part of the project. But number two was the work required to do impact analysis, and especially on larger mainframe systems. Typically, most organizations, and even today, are still doing that work to determine program changes or system changes within the code to accommodate some new feature or capability. That work is typically done manually by hand, inspecting code. And so there are certainly faster, more productive ways to accomplish that, and leveraging the type of tools that we're talking about in the podcast this week and on today's Q&A are examples of technologies that can have a significant impact on reducing your total software delivery lifecycle time. So important tools from my perspective. I think they're incredibly valuable from a business standpoint. Just great tools. Housekeeping. The good coding mug has been a success, and so best question today will get a good coding mug sent to them. I love these things. I'm starting to collect a couple at the house now, and we love them. So best question, I'll determine the winner based on the question, and we'll make sure you get one of those today. Let's see. Let's get right into the questions and then wrap up. Let's see. First question from Paul. Paul writes, what is the difference between static code analysis and dynamic code analysis? Major difference is static code is you're looking at the code at a snapshot in time. It's from a static perspective. And it's very valuable because if you're a developer who may not have experience with a set of programs or a program that you've been assigned to make changes to, then having tools to visually represent or document logic flow and data flow, program structure, will significantly decrease the amount of time required to assess that program to determine what work needs to be done with regards to change to accommodate whatever feature change or addition that you're trying to add to that. And so it's a static code, it's a snapshot in history. Dynamic code analysis is more runtime, real-time information based on the execution of that program or system and the resulting information as a result of that execution. So it's real-time type information, which is incredibly valuable from a debugging standpoint, from an understanding standpoint, from a performance tracking, performance issue standpoint. So static code, snapshot and history of that code and how it works. Tons of great information with regard to that code and how it interoperates with other code. Dynamic code analysis or assessment, runtime, real-time type data. Okay, next question from Lucita. Lucita asks, you indicated on the podcast the importance of these tools in a modern software delivery system. Can you elaborate? Well, I've already talked a little bit about that, Lucita. Again, I think it's just the amount of time that you're able to take out of that software delivery lifecycle. But there are other reasons why you want to do this. I think quality has a huge impact. I mean, if you're dependent upon one's ability to inspect code and to manually identify the tasks or the stories that have to be executed in order to accommodate some change, the best of us are not going to be as good as the machine in identifying where different fields are used, where different files are used, dependencies upstream and downstream of that program. That software, that computer is going to do a much better job of identifying that work. It can do it faster, and I think it can be more effective, producing a higher quality list of work to be done than we can do manually. So I think that having that in your software delivery system is critical. It's even more critical if you're relying on resources who may not have a lot of experience with these systems. A lot of these systems have been operational and executing for years and years and years. And so if you're trying to make modifications to that code with people who do not have that experience in maintaining it, these type of tools are going to have a tremendous impact, again, on speed and again on quality. So I just think it's an important, I call it a feature or capability within my software delivery system, and I think those are the primary reasons why it's important. Let's see. Next question is from Martin. Martin asks, can you describe some use cases for program and application understanding tools? You know, the primary ones, Martin, are code understanding, again, for not just the new developer who may or may not have experience, but for those of us who have been looking at code for a long, long time, the ability to identify program changes required on new additions. I can do it a lot faster, you know, with that type of information, and more importantly, how that information is presented to me. Being able to look at text code on a green screen is certainly can be done. A lot of us have been doing it for a long, long time, but to have structure charts presented that I can look at, even print, you know, can have a huge impact. So code understanding is a use case. If you've been charged with making a change in a particular in a set of code, but you need to understand the impact of that code change, being able to look at the dependencies in that program from an upstream, downstream standpoint is critical. Next use case, code discovery. If I'm trying to determine, what copybooks are being leveraged. Now, there's different ways to do that. I can do that in my SCM, but I can also do that in a good program understanding visualization tool like program analysis from Compuware. Being able to define those dependencies, discover code, discover where data fields are being manipulated. When I say manipulated, where we're adding data to that or we're changing data in that variable, it's easy to find. So code discovery is another use case. I've talked about story task development and planning. I think that this is one of the most underutilized technologies for helping an organization transition to an agile software delivery management system. I think that the information provided by these tools and these technologies help you to segregate work, which can be difficult, especially in very large mainframe complicated systems that are very tightly coupled. Being able to use these technologies to identify what I call segregation points or segregation pieces within that code. We used to do an exercise when I was modernizing code. One of the first steps in that re-engineering effort was to do what I call functionally segregate components of the application. Example might be reporting components or ETL type activity within that code, business rules, screen presentation, user interface. If you can use technologies to segregate these very complicated, very tightly coupled systems into components, and then work on those at a component level, and maybe there are different agile teams assigned to different components within that system in feature branches or however you want to manage that, it becomes much more manageable than trying to have one person make a feature change that's going to impact all of those components. Now, it requires more coordination, more better communication, and hopefully your software delivery system can provide that through your SCM and through other means. But I think that's a better way to do story and task development if I've got that information available to me. The other thing that's critical is complexity. McCabe metrics, things like that, to identify the complexity of a unit of code or a program can be very important and very useful when identifying effort associated with changes to that program. And so from a planning standpoint, that can be a strong use case for these tools. Troubleshooting is a huge opportunity with these technologies, especially that dynamic analysis that we talked about earlier. The ability to execute code and then to visually identify how that code is operating is a tremendous advantage to the developer who is trying to look at either logic issues or performance issues for that matter, and having those metrics available to them very important from a troubleshooting standpoint. And then the last thing comes to mind, dependency identification. Again, if you're being asked to make changes to a system or to code program, being able to quickly identify the impact from an upstream standpoint and a downstream standpoint of that change, tools like this make it certainly a lot easier to do that work and to identify subsequent work that might need to accommodate a specific change. Okay. Let's see. Next question. Can you do impact analysis with these tools? Absolutely. All the things that I've been talking about, the visualization of workflow, data flow, structure chart of the program, information, metric accumulation, and from a runtime, from a dynamic standpoint, the ability to leverage all that information is feedback and input to that analysis and assessment work ethic. Let's see. From Jackson. Jackson asked, what are the biggest business benefits adding these capabilities to our software delivery system. We've talked a lot of those. I think there's a couple things maybe we haven't talked about. Recruiting, I think, is still a significant reason to invest in these type of technologies. It can be scary moving on to or asking developers who may not have had a lot of training on the mainframe in university to come in and to do this type of work. But if you can provide them technologies that will make that transition easier and less scary, I think it has a very strong impact on recruiting new resources that won't be afraid to accept those challenges and to learn new things. Making that transition as easy as possible will have an impact on your ability to get the best and the brightest within your organization. Other business benefits, onboarding time. Think about that. You've got a new developer or you're contracting developers to do maintenance or to make modifications to existing code. And again, they don't have a lot of experience with the platform. Well, there's two hurdles they've got to overcome. First, they've got to go in and try to understand how an existing system that they've been asked to do work on functions. That's a significant learning curve in itself. And these tools can have an opportunity to fix that. But there's also navigating. If you're asking developers, new developers, or developers who don't have experience in that particular system or that platform, you're asking them to leverage platform tools. Typically, it's 3270 green screen technologies to learn, to uncover, to assess, to discover everything that they need to do in order to support the change that they've been asked to make. Learning a new system and learning how to navigate, a new IDE or application development platform. Both of those together can be, can slow people down significantly, rightfully so. So having a more graphical, visual tool to learn about that system and to identify work is a big deal. Business benefits, the other bit of quality planning. Huge benefit there. We used to use the metrics, complexity metrics, in trying to assign some effort estimation to work that had to be done to support some business change or application change that we were making. And so from a planning standpoint, we could do a much better job if we had some idea with regards to the complexity of a particular unit of code. And so that helped significantly. Also, and I've talked about this, but I'll reiterate, the ability to do a better job of identifying work using the computer versus using manual means to create a list of changes that need to be made. The tools can do a much better job, certainly a much faster job. Again, reduction in time, certainly a big business benefit, something that I think Agile is driving, and we ought to all be aware of. Quality. And then the one last thing, and I mentioned this on the podcast, but I think it's important, is the use of these technologies as a strategic tool to help with the transition from waterfall to Agile. I think a lot of people underestimate that type of transition, especially with very large, complex, tightly integrated systems that typically run on the mainframe. Being able to use these tools to identify those functional components within that application. If I can start to segregate reporting, if I can segregate ETL, if I can segregate the UI, if I can pull business rules and extract or to build those into functional components that make up an application, that helps me to assign work to different teams. Again, I've got to have the right technology in place to accommodate parallel type work activities, but you should be able to do that with a modern SCM like ISPW. Then being able to segregate that with these visualization tools will help you with that transition I mean, if you're trying to look at these very large systems and you're trying to define work in 2 week, that can be accomplished in a 2 week sprint without that information, it's very critical. There was a comment on the podcast not long ago, and we were talking about the complexity of these very large systems and how do you break those things down in order to leverage DevOps, in order to leverage Agile, and I think it's through the use of these type of tools and functional segregation of these systems that at least gives you a fighting chance of being able to leverage these techniques. I think that's a huge business benefit to leveraging these application understanding and visualization technologies. And let's see, looks like I got one last question, and this is from Martin. Martin asked, what languages are supported with program analysis? And right now, COBOL PL1, so with our technologies. So anyway, I think that's the answer to that. And I don't see any more questions at this point in time. So we will close it out. Again, I appreciate your time here today. Thank you very much. Last day of vacation, back to the grind on Monday. I've been looking forward to it. I love this stuff. Hopefully you can tell that. Next week's podcast is with a gentleman from Sonar Source. Man, I hope you will be able to listen to that. I speak with Nicholas Bontu, who's the VP of Marketing from Sonar Source, but he comes from a development background. So we get into a fairly good technical discussion on the capabilities of Sonar and what it can do for mainframe targeted code and its use and interoperation with Compuware tools in a modern software delivery pipeline can be leveraged. So interesting conversation. I hope that you will join us. And I think Nicholas may be able to join us for the live Q&A, which will follow not next week, but the week after because it's a holiday. So join us for that. That should be a good conversation. Sonar has done incredible work, obviously not just for the mainframe, but to include the mainframe with regard to being able to leverage technologies and rules to help us produce higher quality code and secure code. And we'll talk about how we do that in that podcast. So I hope that you'll join us for that. Other than that, if you've got questions or you need information about how to get these podcasts or how to get recordings of the live Q&A, you can go to compuware.com/goodcoding, and all that information will be there. You can go back and look at prior episodes, prior live Q&As. And I think that's all I got for today. Back to vacation. You guys have a great week, a great weekend, and I look forward to talking to you next week. Take care. Stay safe. Good coding, everybody.